We don't know why, in particular, bay is a favorite host, but it's a rather convenient host for me because it's something that you can generally field recognize some of the symptoms of the pathogen. The symptoms vary widely on what plant they happen to be on, but on California bay they're relatively distinctive. And the symptoms are a series of leaf spots on the leaves themselves. It doesn't cause disease to the rest of the plant, but on the leaf itself it gets a small darkened lesion where the water accumulates. So if you can imagine the architecture of the individual leaf, however it may be, if you look at the point where the water accumulates, there you often see a black or dead tissue develop with an uneven margin as you approach the remainder of the leaf and some yellowing tissues or chlorotic tissues. Additionally, there may be spots scattered throughout the leaf, and that's where the pathogen is getting established on other places. Pathogen recognition is really problematic. You know, we're looking for sets of symptoms that are mildly unique to the pathogen, but generally quite general to a lot of other disease issues in the redwood region. Redwood is a common host here. The redwood itself, when it's competing for light, whether it's the basal sprouts, the sprouts at the base of the tree, they'll look pretty beat up and ratty over time, and that looks pretty similar to what the pathogen does on redwood. What you're in essence looking for is small lesions on the needles themselves, usually on the second-year needles, widely distributed, not unique to one side of the leaflet or the other, and you know, just an overall degradation in appearance. Redwood is usually pretty healthy looking, so when you start to see problems, you know something might be going on. Madrone is very hard to recognize the pathogen on. And tan oak, again, we're looking for presence of dead trees as a start, and then we're looking for the wounding ooze coming out of the bole of the tan oak trees themselves. Then we need an axe to actually sample for it. In recent weeks, we've actually been able to recognize the pathogen on some of the leaves of the tan oak trees, which, as I understand, is quite unique. In points to the south, it hasn't been that easy to field recognize it. And here, what we're seeing is the midrib of the leaf getting infected and spreading throughout the leaf itself. And that midrib is darkened in color, and there's sort of a non-specific, general, diffuse margined, darkened tissue that forms as it moves throughout the leaf. Huckleberry is supposed to be quite distinctive, and yet whole shoots will die on the huckleberry itself, and you'll get these, you know, darkened tissues and whole, they call them huckleberry canes. Those canes will die. But there are other things that cause problems on huckleberry too. In all conditions, there are other things that cause similar sets of symptoms. There's nothing that's inviolate that allows you to determine that this is the pathogen when you're in the field. You have to be working with a lab, and the lab is the definitive answer to determine whether or not the pathogen is present.
Symptoms caused by Phytophthora ramorum are quite general and often can be confused with symptoms caused by other plant pathogens. Because of this, it is necessary to confirm that plants that supposedly or putatively are infected by Phytophthora ramorum really are infected by this pathogen, and this can be done only through laboratory testing. The problem with testing for Phytophthora ramorum and diagnose it even in the laboratory is that it doesn't grow very easily on a petri dish. So it's not very easy to culture it from infected plants onto a media in the laboratory. And some plant species are particularly difficult for isolations, and in general it is difficult to isolate the organism once you get into the warmer and drier months. From midsummer into the fall, it may be extremely complicated or extremely difficult to isolate this pathogen. This means that a lot of samples that actually are infected by Phytophthora ramorum will result as negatives. So they will not give any viable culture of this pathogen in the lab, and this could be defined as false negatives. False negative plants represent a high risk because they are potentially free to be traded among different regions, and they can be responsible for the introduction of the pathogen. The pathogen that was not detected will, of course, move from the infected plant into the new environment once the plant is being traded or sold or moved. For this reason, the US government has approved the use of a DNA-based diagnostic assay to actually confirm the presence of Phytophthora ramorum in symptomatic plants. This assay can be done only in specialized labs, but it is extremely reliable. It is extremely specific for Phytophthora ramorum, and it has been shown to be consistently superior to culturing of the pathogen in the lab. So if you're dealing with this disease, you need to diagnose it, you need to familiarize yourself with the procedure of collecting plant samples, both for culturing and for DNA extraction. These procedures are slightly different, but they will ensure that the sample will be processed in both ways and come back with the maximum chance for a positive identification in case of presence of the pathogen.
The challenge in training surveyors to recognize P. ramorum in settings outside where it occurs naturally is due to the fact that the symptoms are fairly non-specific. There are many pathogens that can cause similar symptoms. So we try to help our surveyors recognize the generic symptoms, such as occurring on these leaves of rhododendron, dark discoloration that goes through on both sides of the leaf, including a water-soaked or irregular, non-distinct margin between green tissue and the necrotic tissue. On the stem host side, of course, we're looking for the bleeding stem cankers oozing from bark fissures or other discrete areas on the stems of the bark hosts.
You've got a home, you know, as close as 10 feet away from a tree. It's 7-8 times the size of this. That starts to get real scary, especially if you've got loved ones and family in there, you know, and you know there's children living in that house, and those trees represent, you know, every picture ever taken on the res always shows those trees. They become a part of the tribe, of the people. You know, it's something that makes us who we are. The thought of losing that is really scary.
One complication in survey nationally is the huge area we have to cover. So we try to focus our attention by using risk rating systems, which help us identify those areas that are most likely to harbor the pathogen. We employ some elementary plant pathology principles to get at this risk rating, and we call it the disease triangle. The first side of that triangle is, of course, the host, plant material that is susceptible. The second is a suitable environment, and the third is the presence of the pathogen. If you take away any one of those sides of the triangle, then disease does not occur.
The key to doing a good P. ramorum detection survey is to make sure you evaluate the high hazard areas and the places where it's most likely to show up. Right here would be a good area for P. ramorum to get established if it would take in the eastern U.S. You have a stream going right by, which adds moisture to the environment. You have an oak overstory.